I am the CEO and co-founder of CBEX. CBEX is a startup leveraging technology for sustainable agriculture and efficient water management. Over the years, I have worked extensively on developing scalable, data-driven solutions to empower farmers and optimize water use, particularly in regions facing significant resource challenges. So water security is one of the most critical issues of our time, with increasing pressures from climate change, urbanization, desertification, and pollution, and ensuring safe, sustainable, and equitable access to water has never been more important. AI holds immense potential to address these challenges, enhancing monitoring, improving resource allocation, predicting risks, and supporting informed decision-making across water systems. This panel will explore how AI can revolutionize water management, tackling current obstacles and uncovering opportunities to create resilient and sustainable systems that secure water for people and ecosystems alike. Please join me in welcoming our distinguished speakers who bring a wealth of expertise and innovative perspectives to this insightful discussion. So let me start by introducing Mr. Christopher Gusson. Christopher, you are a highly respected authority in the global water sector, serving as the publisher of Global Water Intelligence for over 22 years. Under your leadership, GWI has become the premier source of data and insights on the international water industry. Your expertise lies in water finance and markets, making you a key voice in understanding the economic and strategic dynamics shaping the future of water management worldwide. So thank you for joining us and welcome. And next to him, Dr. Giriraj Amarnath. So Giriraj, you are a distinguished expert in applied remote sensing, water management, and disaster risk resilience. With a PhD from the Indian Space Research Organization, you have contributed to leading institutions like the University of Beirut in Germany and the International Center for Integrated Mountain Development. Since joining the International Water Management Institute in 2007, you have risen to become the research group leader for water risks and development resilience. Your work focuses on leveraging AI and satellite imagery to address water risks and climate resilience, and projects spanning Africa, South Asia, and beyond. Thank you for joining us and welcome. And Brian Dorlu. So Brian, you are the president and founder of Frog Creek Partners, where you have spent the last 8 years developing innovative environmental solutions to protect our water systems. With a background in mining engineering and oil and gas exploration across multiple continents, you bring a unique perspective to tackling water pollution challenges. Under your leadership, Frog Creek Partners has developed technologies like the stormwater filtration system, collaborating with municipalities and private corporations in North America, and exploring expansions into new markets like in Europe and Middle East. So thank you also for joining us. So I will start with you, Christopher. So Christopher, as a publisher of Global Water Intelligence, you have a unique vantage point on global trends and innovations in the water industry. From your perspective, how is AI currently reshaping the water management, and where do you see the greatest untapped potential?
Yes, so it's certainly reshaping my business because the AI industry itself has huge water needs, both in terms of the manufacturing the chips that, that in the process of creating silicon wafers, you have to wash the wafers, and they throw away 70% of the chips because of impurities in the water. And so there's an enormous pressure to get the water technology right in the chip manufacturing industry. And we have a little business in this area, which I bought 10 years ago, and for 9 years it did nothing. But then this year it suddenly exploded, as everyone wanted to understand how they should be using water better in the chip manufacturing. And that's just the beginning of it. The next challenge is in the data centers that run AI. You have huge cooling needs. The faster the chips become, the more energy they consume, the more heat they produce, the more water they need for cooling. And that is going to, again, create huge new demands for water in sort of unlikely places. So as a business, we're really excited about the AI because it is sort of driving a lot of additional revenue for us. But in terms of how it's changing the water industry, there's, I guess, two basic things that happen to water. It gets treated and it gets managed or transported. And AI can have a huge benefit for both of these things, primarily on right-sizing what you're doing. With a treatment plant, you can make sure, for example, desalination, the process of desalination only needs a certain amount of energy, but if you put more energy in, you reach the flat flux rate and it doesn't produce more water. So if you can use AI to continuously measure the temperature and salinity of the water going into the membranes, you can, and then respond to that and optimize it continuously, you can dramatically reduce the amount of energy required in desalination. And similarly with networks, if you can work out where there's capacity in the network and you've got a storm in your wastewater or stormwater network, you can juggle the water around more effectively if you have an AI system which can learn where it can put water according to the flows. So that has been the big sort of commercial opportunity for our subscribers in AI in the water sector.
Yeah, thank you very much. Talking about water management, Giriraj, IWMI has been global leader in sustainable water management, leveraging innovative approaches such as restoring ancient tank cascade systems like in Sri Lanka and implementing digital twin technologies. Could you share how these solutions, particularly the digital twin, are transforming the water resource management and mitigating the risks in regions like Limpopo Basin?
Yeah, thank you for this very important session at the COP16. I think we have a quantum jump in water resource management using sophisticated technology like artificial intelligence in this case, because traditionally water has always been managed by the traditional approaches of taking some weather station, informing policymakers and making some action. There is a significant delays in terms of allocation, resource management, etc. Now, we have seen capabilities in both this region, in Southern Africa and also in Sri Lanka, augmenting the artificial intelligence, the basic role of digitalizing a lot of data sets coming from the field observation or IoT instruments, and then bringing a lot of real-time information, and then try to give a scenario to the policymakers, specifically in Limpopo Basin, to understand what is the surface flow, how much groundwater levels are available, and what we have to do, a kind of a simulation that would offer them using a seasonal forecast information, right? So with increasingly climate change, the lead time for policymakers or at the ministry is a very crucial time to provide credible information. And this is where technology like digital twin can blend the traditional knowledge along with the real-time information to make sure that the needed policy decisions can come out of that action-oriented information. And in the Sri Lanka case, it's a very traditional centuries-old tank cascade systems, basically storing the water in different parts of the river basin. But the limitation was basically sedimentation issues, measuring, lack of weather station data, lack of groundwater data. So we looked at using advanced earth observation data, looked at digital elevation models, understand the small storage systems and identify the challenges. And then that allows really for looking at investments in the tank cascade systems. And again, because you can run a very complex algorithm in artificial compared to 10 years before, where we were using a very traditional modeling systems. Now it can augment whatever the priorities we would like to do. And that's where the beauty of AI comes into providing both for flood risk management, drought and water scarcity challenges. It can provide an immense opportunity. But there are bottlenecks which I will discuss as we go forward. Yeah. Thank you.
Thank you very much. Data, we talk a lot about data. So, Brian, your journey from oil and gas drilling to developing solutions for water management offers a unique perspective. I mean, actually, over the past 8 years, you have addressed environmental challenges in over 50 municipalities. Can you briefly explain what your stormwater filters do today and how they might evolve into AI-driven tools for monitoring and predicting municipal water security, let's say?
Sure, thank you for the question. First, I'd like to thank the organizers for having me and the Sustain panel up here. This is a great honor and a privilege, so thank you. As you stated, I started out my professional career in the oil and gas industry and as a mining engineer, worked for about 20 years there. And on my daughter's 8th birthday at 2:37 in the morning, I shot up in bed with an idea for a stormwater filter. I had learned that scientists have proven that one smoked cigarette butt dropped into a liter of water with 10 minnows will kill half the fish in 4 days. One cigarette butt can kill 5 fish. Plus nicotine kills thousands of insects, millions, trillions of insects every year. So I knew the cigarette butts being littered were a problem, and I was trying to figure out a way to solve that. And literally the idea came to me into a dream. So I developed this thing called the gutter bin stormwater filtration system that sits within a storm drain. So basically it's like a coffee filter for storm drains. There's not a lot of storm drains in Riyadh. I haven't noticed many, but there's plenty of in other places. But where all the water and snow melts, it drains into a hole. You take the lid off and we put our filter in there. It's like a coffee filter for storm drains. You put the lid back on, and as the water flows in with the cigarette butts, the heavy metals, the hydrocarbons, the tire treads, we find baby diapers and hypodermic needles in there. Normally, all that water would go straight to the river or to the ocean while we capture it in the gutter bin. Then we come by once or twice a year and we suck it out with a vacuum truck or by hand and we dump it out. But what's important there is we take measurements. You know, this day you manage what you measure. You got to have measurable and quantifiable results, just like your data. So we built an app on our phone that we go out there and we know who, when, where, when, why, when the gutter bin was serviced, how many pounds of pollution we captured, and all that. So what we do is the gutter bin makes a cleaner environment, which makes cleaner water, which then allows people to reuse their water, which is very, very germane and important in places like Saudi Arabia, where rainwater reuse is going to be, it's already highly necessary. And how that's converting into AI, evolving into AI, I use ChatGPT every day. I mean, just as probably the general user, I write almost every email with it, proposals. I even analyze data and do math. It made my work just as an innovator and entrepreneur so much easier. But the way I see it going is the gutter bin is not only a filter, it's going to be a platform for technology, the IoT, the Internet of Things, where we can put sensors on there like temperature, conductivity, and pH, where we can grab this data in real time or upload it once or twice a year, and then make better stormwater management decisions, because all this stuff on our streets as it drains in is severely affecting everything downstream. And to make them smarter at where the pollution is happening is going to make cities smarter.
Thank you, Brian. So Christopher, back to you. What do you see as the main obstacles to the widespread adoption of AI in the water sector, and how might these challenges can be addressed to unlock its full potential?
So we first got excited about the concept of, you know, big data and machine learning and what have you in the water sector about 10 years ago. And you know, we wrote all kinds of editorials telling people this was the next big thing and they should be paying attention and investing and so forth. But nothing happened. So we did a bit of an investigation to understand why nothing was happening. And what we discovered was that there's a huge amount of what we call digital poverty in the water sector. That most utilities are very risk averse in the way that they work. They hate the idea of things going wrong because that might kill people, so they tend not to try anything new. And big IT projects scare them to death. So what that means is that there are an awful lot of utilities who have no idea where their assets are, no idea what's in their pipes or where it's going, and they like it that way. And there are a smaller number of utilities who have less fear of IT projects, and they've started to invest. And what they're finding is that it just gets better and better. Once you start doing things with data, you can, it becomes a way of life, and it reshapes the way that the utility operates. And so we're seeing this sort of much broader experience of how utilities are. Some of them, just looking for every possible sort of data. I mean, there was one in Australia which was sort of listening out to see, putting acoustic meters into houses so that they could tell the difference between somebody using a dishwasher and somebody having a shower. And they could then, provide with the bills, how many times people showered as well as used the dishwasher, so that people could understand where their water use was. And then other places, as I say, which have got absolutely nothing. So balancing that out is really the big challenge for the water utility sector.
Yeah, I mean, same actually for Giriraj. And IWMI often emphasizes the integration of hydrological, socio-economic, and ecological systems. So how does AI today help balance these complex factors to ensure both sustainability and equity in the water use?
Yeah, thank you. I think AI for us is an instrument, and data is gold or oil today, right? So now AI can certainly excel bringing a huge volume of data. In the past, we only understand the biophysical aspect of the hydrology, because the survey data, people perception, water bodies, nature-based solution, they all looked in silo. Now with this technology integration, we can bring everything in one computer interface, and we can understand the process between the climate impact to water cycle. How does the human population risk is going to impact those water system, and also how the ecological resistance would able to hold on that. So we can bring this, blending these three aspects in a single interface, and the good part of that we can then take into the next set of uses. A high-level computing models, providing a necessary policy or an dialogue that will bring together different uses, and then there can be a equitable access, or I would say a digitally inclusive governance mechanism can be brought in by this entire framework. So I would say that unlike in the past, there is always farmers have challenges of equitable access to water compared to industry. Industry consume a lot of water for industry purpose or domestic utilization. So you can bring everybody into a table, explain them there is a clear challenges of water availability, and that's the way we can go with this adoption of this useful and beautiful technology. Thank you.
Okay, thank you. So let's keep talking about impact, Brian. What has been the tangible impact of your stormwater filtration systems on the communities and municipalities you have worked with? So, and also, how do you envision AI enhancing this impact or make it scalable, particularly in terms of scalability and efficiency? So,
good question. Thank you. So we're in about 22 different states and 4 different provinces in Canada, in North America. And we work with 2 cities in Colorado of note, Colorado Springs and Vail, Colorado. Vail is a small little town at the headwaters of Gore Creek. And like Christopher was talking about, you have these communities that really embrace data and change and so forth, and Vail is one of them. We put about 280 gutter bans in Vail, Colorado about a year and a half ago. And in the first year, we captured 10,000 kilograms of pollution from this, which is a lot. I mean, you think about 10,000 kilograms, plus we figure out about 20 million liters of water replenished. And of note, for the first time in 15 years, this tiny little mountain stream of Gore Creek has seen aquatic insect populations increase. So when you have insects, a lot of people don't like mosquitoes and insects, but they're the basal life form that feeds everything else besides grass. So when you see these insect populations increase, and there's a direct correlation to a new filtration effort in a relatively clean town like Vail, imagine what it would do like Detroit or London or wherever. But we're finding that the average gutter bin captures per storm drain. But every storm drain is contributing on average about 100 kilograms of pollution per year to a river, approximately. That includes sediment, microplastic trash, and other things, hydrocarbons. So that's a big deal. Now, where is AI going to make a direct impact to the efficiency and scalability of this? I see one of the biggest things is taking this logjam of data that these organizations have around the globe, like conservation districts, for example, in America, have been capturing data for decades about streams, waters, temperatures, and all this stuff, and they don't use it that much. Now we're going to be able to plug it into AI, figure out what's been going on for decades, make real-world changes. But then that's what that's going to do is it's going to allow cities to more effectively deploy capital and put filters or other infrastructure in place to use their money better.
Okay. Thank you. Christopher, so drawing from GWA data and insights, what trends or opportunities stand out today for AI's role in transforming global water security, particularly in addressing the needs of underserved markets?
I guess the thing which I'm most optimistic about is that we will address this problem of data poverty. And I suppose that the indicator I was looking at that shows that we can be optimistic is the amount of smart meters that are being put into water systems around the world. I mean, it seems that the meter providers are really pushing this on the utilities. And I mean, we're seeing this sort of adoption curve, and which we've been researching this and published something 2 weeks ago showing how we're at the beginning of this sort of real asymptotic increase in the adoption of smart meters, and that will create a huge wealth of data, which will put a lot of utilities on a proper digital journey. In terms of the sort of treatment side of things, I think that actually this is an area where sort of Saudi Arabia is sort of leading. Aqua Power, which is the sort of leading private producer of desalinated water in the world, when they design a desal plant these days, they use terabytes of data from minute-by-minute reports from their existing plants to tell them how to design the next plant so that it will be more efficient than the last. And this has been one of the big drivers about why Aqua Power has been able to drive down the cost of desalinated water from over 50 cents to below 40 cents over the past decade. It has been very much a data-driven process. And I can see that process of making desalination more affordable is actually going to benefit huge numbers of people around the world.
Thank you. Giriraj, we are talking here about floods of data, but if we get back to the floods of water, floods remain a critical challenge in many parts of the world. Based on IWMI expertise in flood protection and disaster preparedness, what role does AI play in enhancing early warning systems? And how do you see these technologies scaling to vulnerable regions globally?
Yeah. That's a very important question. I think worldwide we see an average of 400 to 500 large-scale disasters happens each year, and flood takes a biggest toll when it comes to exposure to GDP as well as to the vulnerable region specifically. The developed countries do have better infrastructure, so their exposure is quite low. I think few years back we were unable to answer some of the questions on complex flood modeling, and I think artificial intelligence with LLM models and other machine learning approaches, today we can bring integrated thinking of ground-based observation, satellite images, measuring the river flow. You can combine all this and understand the reliability or the accuracy of the flood prediction, because often the agencies have to have a trust in the flood predictions to evacuate people, mobilize the resources. That was a challenge in the years back. I think there are a lot of countries have already demonstrated. But answering to your question on vulnerable region, I think we need to make some of those into a public-private partnership model. How does a vulnerable region can have an affordable open source models that can be adopted? I think somewhere there should be a viable business model, because flood is not just for informing decision, but it can create a lot of value chain. Flood with the health ministry in terms of waterborne diseases, vaccination, a lot of medical infrastructures can also come in into that. There can be a lot of private sector can come in. It could be useful for flood insurance. Reinsurers can work together. So we need to look at a different business model, not just a technology that can be easily reached to a vulnerable region. So we need to look a wider spectrum of data chain and also the partnership, and making sure they are affordable and reliable and also sustainable as well. So we need to make sure all these aspects have to be looked at when we talk about focus of vulnerable region. Thank you.
Thank you. Brian, as someone deeply involved in developing practical solutions for urban water management and security, what challenges do you foresee in integrating AI into municipal systems globally? And what opportunities excite you most about the evolution?
Well, I think it was Albert Einstein that said the definition of insanity is doing the same